In UniFi Network Controller, if you go to your VLAN setting, you can enable content filtering. In the security setting, you can enable ad blocking. So Ubiquiti made weird decision to separate these features in different places, but under the hood, they are related to one thing, DNS filter. So in this video, we will discuss if you only have ad blocking enabled, how the DNS works inside your UniFi gateway. What if you only have content filtering enabled, how the situation will be different. If you have both ad blocking and content filtering enabled, what's the complete picture inside your gateway. Then we will discuss if you try to bypass your gateway's DNS setting, whether the ad blocking and the content filtering will still work. You may be surprised with the answer. And then in the end, let's talk about how we can whitelist or blacklist some specific domain names. Okay, there will be a lot of things to cover. Let's get started. At this moment, I have both ad blocking and content filtering disabled. If I check my current DNS setting in the UniFi gateway, for the primary internet one part, I have the DNS server set to 9999, and if I go to VLAN 10 under DHCP, the DNS server says alter. I have already covered the details in some of my previous videos in details. Ubiquiti will run a DNS mask in each VLAN to act as internal DNS server. My VLAN 10 client will retrieve the DNS setting from DHCP. Whenever the client wants to query a DNS domain name, it will send the query to this particular IP address for the gateway's VLAN 10 IP address, running DNS mask as the DNS service. Then, based on the DNS mask internal configuration, which is based on the primary one parse DNS setting, it will connect the 9999 to resolve the domain name. So in this process, there's no DNS filtering because we didn't enable any of these two features, right? You will not achieve ad blocking and content filtering. I will not waste your time go to the details because this is the very simple regular situation. So let's jump to next scenario. In this scenario, let's only enable ad blocking. Go to security, enable ad blocking. I need to select VLANs and apply changes. To understand what happened after we enable ad blocking for VLAN 10, let me SSH into the UXG Pro. First, check what processes are listening on port 53, which is for DNS. I'm running netstat command and only show the 53 port ones. No surprise, most of them are running by DNS mask. You can tell from the very last column. And from the IP address part, DNS mask is listening on localhost, each VLAN, including the layer 3 switch VLAN. But this time, there's a new IP address, which is this one. Only after we enabled the DNS filter, we will get this new entry, and it is also running DNS mask, but with this very strange IP address. If you check this RFC 5737, you will see this IP address is part of the so-called documentation address blocks. So it's not supposed to be used as regular internet IP address. It's only for documentation purpose. Because we have a strange new IP address, let me show the current routing. IP route. This is the routing for the new subnet, and here is for the device DNS filter. This is a new device after we enable one of the DNS filtering functionalities from the UniFi Network Controller. Because it is a regular Linux device, let me use ifconfig, try to see what's inside the new device. You can see it has this IPv4 IP address. Now we know a DNS filter thing is running. Let me run another command. PS, try to show what processes have filter in it. It returns two interesting processes. The first one is called UTM, DNS filter capture. It is capturing Ethernet 3 3.10. Ethernet 3 is the LAN port for the UniFi Gateway. .10 means it's for VLAN 10. Remember, we enabled the ad blocking for VLAN 10, right? V6 is just about how to do the logging. And the second line is more interesting. See, the command is DNS mask, but it's using some interesting configurations in this folder, run DNS filter folder. Later we will check what's inside. But before that, see the process name for this filter capturing thing. It starts with UTM. If I am not wrong, UTM stands for Unified Threat Management. I cannot find any information on the internet regarding how Ubiquiti is related to UTM, but interestingly, it is using some UTM things to achieve the DNS filter. Now let's go to this folder to see what configurations are inside it. See the interesting name as list, blacklist, whitelist. We will talk about the three lists later. Let's first check the config file. It simply lists these three lists. Show the other one, which is the resolve config. I assume in this one, you should be able to find the next level DNS resolver. Let's look into it. It's super simple. It only lists a name server. Does this look familiar? Let me exit it. See, previously when we ran the net stat command, we found this one, right? This is the exact same DNS server listed in the resolve config file, and this server is running DNS mask. As shown in the diagram, basically once you enable the ad blocking, the system runs DNS mask on two different IP addresses. One is the .1, the other one is .2. They are both internal DNS servers, and they are all using the documentation IP addresses. Then go back to the three list thing. Whitelist and the blacklist, we will talk about them at the end of the video. For this scenario, let's look into the s.list. Just a super long list of domain names for S website. No surprise, internally, the gateway will use this S list to filter out those S websites. That's how the S blocking works. But we still don't understand how the DNS query is done inside the gateway yet. So we know there are different DNS mask servers, but how they interact, how in the end, if it is a S set, how it's blocked, if it's not S site, how it's going out to the 9999 at the end. So let's find it out. Because all this traffic will happen inside the gateway, those interfaces may not be exposed to outside. So to understand the internal network traffic, let me run TCP dump inside the gateway. Here I'm saying for all the interfaces, write the output to this file. Let me start the capturing. From the right side Linux client, let me dig at service.google.com. It's getting data back from the UniFi Gateway. It did get answer back because here I see 1, but the answers are 0. So in this way, we achieve the ad blocking. Let's dig another website, example.com. Got answer back, and also from the same gateway IP address, and we got the correct IP address back. Let me stop the capturing in the router. Then let me copy the file from the UniFi Gateway to the client. Okay, done. In Wireshark, I already opened the file and I filter the display to DNS only. This is the first frame for our first testing. The client tried to resolve at service.google.com, and the request was sent from the Linux machine in VLAN 10 to the gateway IP address for VLAN 10, as shown here in the first arrow. Then the second frame is a miracle. See, all of a sudden, the destination IP address was changed from the gateway IP address to this strange documentation IP address, the .2 one, shown in the second arrow. We will find out how this happens. Let's put it aside. You can see this .2 IP address, it directly processed the request and sent the answer back to the Linux client. It didn't go further to send the request to 9999. Why is that? Because we tried to resolve a ad website and it was rejected by the DNS filter because it has the list of all the ads site, right? So then step by step, the answer was sent back from the gateway IP address back to the client. This is a ad blocking in action. In our second try, we query example.com. So in the same way, the client first sent the request to the gateway. In similar way, the IP address is changed to the DNS filter. Then DNS filter checked the as list, couldn't find example.com, so it is not as. It will continue furtherly send the query to the 9999, right? We can see that this one is from the .2 to .1, from the .2 to .1. Why this happens? We will look into the backend. You will see it's due to a configuration file. And then later, a query is sent out from the .1 to outside world to 9999. And then it got the result back. So this is the second example. We see how it works in action if the domain name is not a S website. Okay, now we have multiple things to find out from the backend. First, how this miracle happens. Why the query all of a sudden sent from the gateway regular IP address to this weird documentation IP address. Second thing is why, if it's not a S website, this DNS mask will send the query to another one. How this happens. The third one, when it reached final DNS mask, how it decides to send the request to outside world to 9999. Let me use the SSH session to show you. First, about this part, let me show you the IP tables. I want to show you the net table. And see this chain, DNS filter, it has two rules, one for TCP, the other one for UDP. If the source is in VLAN 10, see the miracle is here. If it's UDP, if the destination port number is domain means DNS, yes, our case is DNS, then it will do what? It will change your destination IP address and port number to this, no matter what's your source IP address. This kind of thing is called DNet. If you are interested, you can do your research about what's DNet. So DNet stands for Destination Network Address Translation. It's a technique to transparently change the destination IP address and perform the inverse function for any replies. This is how the miracle is realized. It is using the DNet technique to change the IP address from this one to this new one. So now we are good with this one, right? Then let's see if the website is not a S website, why this DNS mask decides to forward the request to another DNS mask, why this jump happens. Let me go to the DNS filter configuration folder one more time. Let's display this again. See this familiar one-line simple configuration? What it really says is if this DNS mask couldn't resolve it, for example, if it's not a S website, it need to forward, right? Forward to what? To this new DNS server, which is this one. That's how this third error happened. So now the DNS query reaches this DNS mask. Then why this DNS mask decide to forward it to 9999? It is the regular UniFi Gateway's DNS mask resolving configuration. Let me show you where it is. It is in the dns.config.d folder. And it should be inside this one. Okay, it simply configure the 9999 as the next server. Why 9999? Because we configured it so. In the UniFi Network Controller, earlier we configured the primary one parse DNS server to 9999, right? That's how this DNS mask knows that. Okay, so we have already answered the 3 main questions about this complete process. Hopefully you understand when we only enable ad blocking, depending on whether a website is ad or not, how the system will resolve the DNS domain name. Let's move on. In this scenario, let's only enable content filtering. To clean up, I need to first disable ad blocking in UniFi Network Controller, then go to Networks. For VLAN 10, let me enable content filtering. So I have 2 options, work or family. The technical difference is super simple. Later you will see. But for this video, let me choose family. Doesn't matter. Enable it. Apply changes. Now we only have content filtering enabled. In the same way, in SSH for the UXG Pro, let me run TCP dump and save the captured frames in a file. Then in the right side Linux client, let me dig a special domain name just to showcase something that will be blocked. badexample.com dig. It's from the UniFi Gateway. The status for the dig is NX domain. It is an error. You can also see from the answer count is 0. There's no answer back. There's an error. So in this way, this bad domain is blocked by the UniFi Gateway. Unlike the ad blocking, Gateway will return all 0 IP address. Here for the domains that the gateway wants to block, it's even more brutal. It will simply return a NX domain. Then let's check what's captured in the UniFi Gateway. This is the very first frame for the Linux client to query badexample.com. It's sent to the UniFi Gateway as shown in the diagram as well, no problem. Then just like in the ad blocking case, in the second frame you can see the destination IP address was changed from this first DNS mask to the second DNS mask IP address. We already knew how it happened. Move on. Then the second DNS mask send the query to this one. That's something new, right? We don't know what's this. And see then what happened. This external DNS server returned back to the DNS filter, then at the end to the Linux client. The interesting thing we want to understand more in this scenario is what's this 185 something IP address and why at the end, even though the external DNS server rarely returned back, but why it got the error, right? See the query response from the external DNS server, no such name. It's blocked. That's the purpose of the content filter, right? To understand what's this 185 server, it's also a good idea to know the domain name for a IP address. Let me do that. I simply run dig command with the X parameter so that I can know the domain name. This is the domain name. It's from cleanbrowsing.org. And for this family content filtering, it is using this particular service. In this video, I'm not going to waste your time and switch to work, but basically it works in the exact same way. The only difference is it will use another IP address as shown in the diagram. And if I try to get the domain name for that work IP address, you can see it's adult filter DNS, but from the same clean browsing org. Now you may realize how the content filtering is supported in UniFi Gateway. It involved 2 different things. First, it used the same DNS filter just like the ad filter, and then the real blocking is not really done by the DNS filter, it's done by an external service, and apparently the external service is hard-coded and it is from cleanbrowsing.org. For different content filtering type, work or family, it's just different service provided by the cleanbrowsing.org. Okay, because of the detailed detailed analysis in the ad blocking scenario. For this scenario, we don't need to go through all the DNS setting anymore because it works in the same way. But I do want to show you something which are different than the ad blocking. First, remember in the ad blocking, it has the as list for the DNS filter, right? But now we disable the ad blocking, even though the DNS filter is still running. Let's see what's in the as list. Let me go to the DNS filter configuration folder. You can see the files are still here, but this time the as list is showing empty. To support content filtering, the DNS filter has to be running. So the approach taken by Ubiquiti is to simply clear the as list. That's how simple it is. Okay. Then another thing I want to show you is why this DNS filter DNS mask is able to forward the DNS query to external clean browsing service. Let's check it. It's simply done by the resolver configuration for DNS filter, which is this file. Display it. It's as simple as previous case, but this time, instead of pointing to the .1 internal DNS mask server, this time for content filtering, it is pointing directly to the hard-coded external clean browsing service. And depending on whether you choose work or family, this IP address will be slightly different as shown here in the diagram. Okay, let's move on. In this scenario, we will have both ad blocking and content filtering enabled. Let me make the setting in UniFi Network Controller. We already have VLAN 10 enabled for content filtering. Then let me re-enable ad blocking for VLAN 10. If you check the diagram and compare this diagram with previous one where we only have content filtering enabled, you can see they are almost identical. The only difference is now because we enable ad blocking, the as.list is not empty. That's it. Then let's validate it in the SSH session. Let me start capturing. Then in the right side Linux, dig badexample.com. Remember in previous scenario, it was blocked by clean browsing, right? So now let me do it again. Next, the main error, answer 0 as expected. Then let me dig the adservice.google.com. It is supposed to be blocked by ad blocking, right? Do it. The same result, or 0 return. Now let me show you the captured frames in Wireshark. The first try, the bad example, starts from here, and let's quickly skip the beginning ones. See, starting from this one, once the query is in the second DNS mask, it directly sends the query to the external clean browsing DNS service. It didn't forward to this third DNS mask, right? Just like in previous scenario. If we go to the ad blocking try, see, starting from this one, it's super simple. From the Linux client to the VLAN 10 UniFi Gateway IP address, then the IP address is changed to the second DNS mask. Then the second DNS mask directly returned. It didn't send to external one as expected. It also didn't send to the third DNS mask. Instead, it directly returned the results. Okay, and if you want, you can check the as list. You can see now it's not empty. That's why it is able to block our Google Ad Service domain name query. So before proceeding, there's one thing I want to mention. Some of you may already notice. Once we enable the content filtering, it doesn't matter whether you have ad block enabled or not. The DNS mask, this one, will not forward the query to external DNS server to this one anymore. It will directly communicate with the external DNS server, which means whatever you set in your internet setting about DNS server, for example, here I set it to 9999, it will be overwritten. It will never be effective. However, keep in mind the content filtering and ad blocking, they are both enabled on the VLAN level. So it is possible that for selective VLANs, you want to enable the DNS filter, but for the others, you don't. In that case, your internet DNS server is still effective for the other VLANs, right? Okay, now let's move on. This scenario will be an interesting one. In your VLAN setting, you can change the DHCP DNS server, or in your client, you can customize the network setting. For example, here, let me change the DNS to 1.1.1. Okay, apply changes, disconnect, reconnect. Okay, now the setting is effective. At this moment, the UniFi Gateway has both ad blocking and content filtering enabled. But at the same time, from the client side, I choose to use my own custom DNS server. So these two things are conflicting, right? Let's see how the system will behave. From the SSH session, let me start capturing. Okay, started. Then from the Linux machine, let me dig a bad example. Try to bypass the DNS filter. See the result, the same NX domain, and the DNS query failed. You may wonder, why is that? We are supposed to be able to bypass it, right? So then let's see what's captured using Wireshark. The first frame starts from here. See the Linux client send the DNS query to 1111. Perfect, because we wanted to do so, right? So far so good for the very first frame. Then the second one, see, strangely, this 1111 was replaced by the DNS mask running against the document IP address. Remember, we already found out why this type of replacement happened. It's because there is a IP table rule on the NAT table to use DNAT technique to replace the destination IP address, right? The exact same thing happened. Why it happened? Because no matter what, your packet need to go through the IP tables. So you cannot walk around it. Then you still need to go through the same DNS filter process. That's why the bad example DNS query failed. At the end, this DNS mask still need to forward your query to clean browsing. This is interesting, right? Just by using DNAT, it completely blocked the client's custom way to modify the DNS server. But unfortunately, this thing is only possible now in UniFi Gateway for the content filtering. So I hope in the future Ubiquiti can add DNAT support in the UI so that we have a better way to block clients' custom DNS setting even without enabling content filtering in UniFi Gateway. Okay? Let's move on to the very last topic. Let's talk about how we can whitelist or blacklist the domain names. Now we have the wonderful ad blocking and content filtering. However, for ad blocking, it's using the s.list downloaded from internet by UniFi Gateway. And for content filtering, it's hard-coded to forward the query to a fixed service provider, the cleanbrowsing.org. It might happen that you don't like the result they provided. You want to overwrite their result. Let's see how we can achieve that. To do that, let me first restore the Linux client's DNS setting, change it back to automatic. And in the UniFi Gateway, now I have both ad blocking and content filtering enabled. If you remember, for badexample.com, it is blocked by clean browsing, right? So let's say I do want to visit that badexample.com. So I do not want it to be blocked. How I can do that? Go to security, firewall rules. Make sure you are at the simple tab. Let me create one. Let me say whitelist badexample.com. Actions allow, and the destination, choose domain name. Here I say badexample.com. For source network, let me choose VLAN 10. Add rule. Okay, it's effective. Let's try it out. From the Linux client, let me dig badexample.com. This time, the status is no error. Finally, we can see the IP address for this domain name. So that means our whitelist works. Then let's investigate how the whitelist works. Remember, we have the DNS filter configuration folder, right? Let me cd to it. Now let's see what's inside this whitelist. Okay, not only the ones we just added in traffic rule, but also some other entries. They may look familiar to you. For example, the UI UniFi. For example, this one is a custom DNS entry I created. The whitelist include all the domain names you do want to support in your original internal DNS. And additionally, you can add your entries to it. For example, this badexample.com is very straightforward, right? You may think beside the whitelist, there's another file, blacklist. It must be how the blacklist works, right? The answer is no. Let me show you. In the same way, in traffic rule, let me create another entry because x.com is not blocked by clean browsing, right? So let's say now I don't like it. I want to blacklist it. Action, I want to say block. Destination, domain name, and let me add x.com here. Select VLAN 10, add rule. Okay, now we have this one up and running, right? Let me try dig x.com. The dig still works. There's no error, and I do get result back. So you may think this traffic rule completely failed, right? But hold on, let's try another way to access x.com. Let me ping it. See, you cannot ping it. You cannot really visit it. The only thing that still works is you can get IP address back. That's it. Just by the end result, you can understand internally it must work differently than whitelist, right? So let's confirm that in the SSH. Let me refresh the file list. See, the blacklist file is still showing 0. That means the blacklist is not supported by using the blacklist file. This explains why we can still dig. We can still get the IP address back, right? But it cannot explain why we cannot ping it. We cannot ping it must because something block it, right? If we go to the IP tables, see, in the IP table, you can find this particular one. It is a return. I assume this one is for the previous whitelist. Later, you see this one. This is a drop. I assume this is for the blacklist. But let's validate it. Let me use the drop one as example. See how it works? It will drop if the source IP address is within this IP set and if the destination IP address is within this IP set. Then what are these two IP sets? Let me launch another SSH session to show you. Let's first check this source IP set. It is defined by two subsets. This one is for IPv4. Let me display it. Now we get answer back, right? So as long as the source IP address is from VLAN 10, that meet the condition for the source IP set. Then let's check the destination IP set. Again, I need to drill down to this one. Are these four IP address familiar? They are the ones for x.com. In this way, what this drop IP table rule really means is as long as VLAN 10 wants to access x.com, the gateway will drop the packet. In my opinion, the blacklist is not really completely implemented because it doesn't really block the domain name query, but it does block any other possible traffic. But for whitelist, it seems it's fully implemented. Okay, this is the end of the video. Thanks for watching.